Still on this question, please show them the question. This question on Hess law. We are given these three equations and the enthalpy changes, as you can see, and then asked to find the enthalpy change of this particular equation. As we have been doing, as we have been saying, when solving for this equation, we will need to rearrange these three equations to suit this particular equation so that we can get the enthalpy change of this equation. So we're going to be starting with 2CO2. We're going to go and look for where can we see 2CO2 in these three equations. Class, work with me. Where can we see 2CO2 in these three? Where can we see it? The second one. The third. Look at 2CO2. Class, 2CO2 is occurring on the third equation on the right hand. But here is on the left hand. What do we need to do to this to adjust it to be like this? So we have to reverse equation 3, right? So we're going to say reversing equation 3. Reversing what? What are we going to have to reverse it? 2CO plus to give plus. Now when you reverse an equation, what happens to the enthalpy change? The sign change from positive to. Thank you. You have started getting it, Abby? Yes. Good. You see, practice makes. But as I'm taking more examples, you'll be getting it. I told you. Imagine you gave up that first time, you just go and not understanding, you just went home. Class, so we have settled CO2, right? Let's go to H2O. Where can we find H2O in these three equations? Second equation, right? It's on the left-hand side, right? Left-hand side, left-hand side. And it's occurring once, occurring. So our H2O equation is okay, right? So we don't do anything to our H2O equation. We don't do anything to our H2O because it's okay, it's okay. So since it's okay, our delta H is also the same, right? It doesn't change. Class, let's go to C2H2. Where can we see C2H2 in the equation? First. But it's on the left, right? This one is on the right. So what needs to be done to this guy? We have to reverse. We have to do what? Reverse it. Let's reverse this. Reversing this, so we'll say reversing equation. What are we going to have? Yes. To give C2H2 plus 2H. When you reverse an equation, what happens to the enthalpy change? -2. Now if you're in exam after doing these three, if you are sure of what you did, just add up these enthalpy changes and get your final. But you're not still confident, you now have to go and check, oh, I've done it well. Let me add up the three and see, really give me this equation, I'm wasting time. But someone that is very confident already knows it and say, okay, I've not made any mistake. Everybody's in tune now. Class, remaining oxygen though. But class, do you know that by balancing others, oxygen is balanced? Let me show you. Class, we should have 5/2O2 on the right hand. What is 5/2? 2 point. Or 2/1/2, right? Let us see if these are our three equations we have arranged, will give us this. Five over 2O2. Class, how many oxygen do we have on the right hand side? 7/2 plus 1 over. What is 7/2 plus 1 over? Eight over 2 giving you what? 4. But in our main equation, we need the oxygen to be 5/2. Good. 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 not balanced well. Because if you look at, we have 3H2O and H2O giving you 4H2, and we have only 1H2O here, class. Something must be. Class, see what we are going to do. Remember that we will not do anything to equation 2, class. Class, actually, we are going to multiply equation 2 by 2. Why are we multiplying equation 2 by 2? By the time we look up, class, let me show you my reason. If I multiply equation 2 by, I will have 2H2O plus 2H2, 2 times 1 over 2 will give me 1. Will give me what? 2 times 1 over 2 give me what? I won't just multiply by 2, I will also reverse. I also do what? Multiplying equation 2 by 2 and reversing it, I will have, and I'll show you why. I'll show you, I will have O2 plus 2H, multiply by 2 now, 2H2, 2 times 1 over 2 is O2, right? To give 2 times H2O. You know why I reverse it? When I'm combining these 3 equations, class, and I have 3H2O here and I have 2H2O here. Okay, let me remind you of something. Continue. If I have 3H2O on the right hand side, and I have 2H2O on the right, and I have 3H2O on the left. If 2H2O cancels 2H2O here, how many H2O will be remaining here? To give me exactly 1 H2, and that's the 1 H2O I need in my main question. 1 H2, that's why I need to reverse. I needed to reverse this. I didn't just reverse, I multiply by 2. Reverse and multiply by 2. Reverse means that this change from negative to positive. My enthalpy change will change from negative to what? And also multiply by 2. And also multiply by, because we reverse and multiply by 2. Don't forget that the explanation is still going to be on the channel. You can go and rewatch several times and understand. 71.2 times 2 will give you what? 71.2 times 2. 142.4 kilo. Let me count one more time. In case for someone that does not have data. Let me count one more time. Lastly, let me count one more time. Okay? So, okay, let me finish first. Now, when I'm coming again, it will not be videoing. When I'm coming again, it will not be, let me finish at one, let me be done with video. Now, having rearranged the equations, we're now going to add up the enthalpy changes. Minus 87.9 plus 142.4 plus 94. Someone should help me. What will be the enthalpy change of this reaction now? Minus 87.9 plus 142.4 plus 94.5. 14 plus 149 kilojoules plus 149 kilojoules. So we are done with this aspect. Watch out for the next video. All right.